Hi, welcome to Statics of Solid Mechanics tutorials. My name is Adam Gatugo, and in today's tutorial, I will take you to resolving the four x and y components of a given force. Thanks for joining me. Given this inclined force to be 100 Newton, it means the magnitude of the force is 100 Newton. So using your SOHCAHTOA, you could resolve the forces into its x and y components. You have the sine theta using your SOHCAHTOA, sine theta equals to Fy over F, and then sine cos theta equals to Fs over X, tan theta also equals to Fy over X. So the x component of the force becomes F cos theta, and then the y component of the force also becomes F sine theta. The magnitude of the force I've earlier said is 100 Newton. So when you want to find that in a formula, you can say that from here F equals to Fs over Fs over cos theta, and then also from here F equals to Fy over sine theta. And so when you do that carefully, you realize that the magnitude of your F force will be 100 Newton. Now let's take a look at this question and solve it. The question reads, in the design of a control mechanism, it is determined that a rod AB transmits a 260 Newton force P to crank BC. Determine the S and Y scalar components of P. Now this is the given force P equals to 260 Newton, and then it's been inclined. We want to find its x and y components. This is what we've been given. P equals to 260 Newton. And now we've been given this position. Let's say A, that's the S component, to be 12 meters, and then the Y position to be 5 meters. And so using your Pythagoras theorem, you can determine the value of the hypotenuse here. So you slot in your values. 12 squared plus 5 squared should give you the c squared, and then when you punch your calculator, well, you will get 169, and then you take square root of both sides, you'll get c to be 13. That's the hypotenuse here. Or you can also go this way. Probably you don't want to find hypotenuse, you can take tan theta to be opposite over adjacent, so 5 over 12. Then you get your theta. Maybe you want to find the value of theta, you have the tan inverse of 5 over 12 to give you theta is equals to 22.6199 degrees. Or in the sine theta, you want to find the value of theta. Sine theta equals to 5 over 13, and so you have theta equals to sine inverse of 5 over 13, and then when you punch your calculator, well, you get theta to be 22.6199 degrees. The same way you take it for cos theta. Cos theta equals to adjacent, that's 12 over the hypotenuse 13, so cos theta equals to 12 over 13, and then theta equals to cos inverse of 12 over 13. When you punch your calculator, well, you will get the value of theta to be 22.6199 degrees. Now we're looking for the S scalar component of P, that's PS. And so from this particular diagram, we can see that cos theta equals to negative PS, because it's going to the other side, that's the negative side of the x-axis, and we can see the arrow here moving towards the opposite side of the x-axis, so it's negative to it. So we have cos theta equals to negative PS over the hypotenuse, that's P, the P force. So we have cos theta equals to negative PS over P. Then when you make PS the subject, because we are looking for the S component of the force, so you have PS to negative PF to be equal to P cos theta, and then negative PS again. Here you slot in the values of the P force, that's the magnitude of the P, to be 260 Newton cos theta we have just determined theta to be 22.6199 degrees, and so when you punch your calculator, well, you get P equals to 239.999 Newton. You negate this one because you want to make the Px the subject, so Ps equals to negative 239.9999 Newton. And then the y scalar component of the force. From here again, we can see sin theta, the opposite here, over the hypotenuse. So the y component is also going downwards, and so you have negative py over p. And so when you want to make the y component the subject, you have negative py to be equals to p sin theta, and then you know the value of p, so you slot in carefully your values into this particular expression, then you get your py to be equals to negative 260 times sin theta, and then theta, you know it to be 22.6199 degrees. And so when you punch your calculator, well, you will get the value of the the y scalar component of p to be negative 100.0001 Newton.